design, track measurements, Six Sigma problem solving, mechanical quality system, mechanical best way processes. Lisa also served as chairman of the Advanced Technology Safety Committee for the Association of American Railroads. She came to BNSF from Delphi Corporation, where she had a number of assignments in product engineering, quality assurance, and strategic planning. She holds a BS degree in mechanical engineering from the University of Dayton and Masters of Science in Mathematics from Wright State University. I see some high fives going on here. I don't know what's going on between our pros. Keynote speaker. She's an ASQ certified quality professional holding several certifications, including Six Sigma Black Belt. And the most important thing, she has been happily married over 31 years to her patient husband, Mike, and is the mother of 3 wonderful children, Anthony, Karen, and Chloe. So we are more than delighted to have Lisa Stapler here in UP.
All right. You'd be glad to know that my husband also would tell you that he's been happily married for 31 years, especially if he was here with me right now. I'm sure you gentlemen who've been happily married for a number of years can relate. Thank you very much. 3 topics I want to cover tonight. I want to give you a little bit of overview of TTCI, and I will say for the youngsters in this room, think about this as you're thinking about plans for post-graduation. You know, it's a great place. Pueblo is not necessarily have the beautiful lake out there like you have. There's really no reason to bring a snowmobile, but we've got mountains and you can see them in the distance. I also want to talk a little bit about the AAR Strategic Research Program. If there's anything that TTCI is known for, it is the strategic research that we do for the Association of American Railroads. And then finally, I'll end up with a couple of highlights from the 2013 research program. The types of highlights that you'll see if you're coming to the research review, another shameless plug here for TTCI, on April 1st and 2nd in Colorado Springs and Pueblo, Colorado. Okay, so let's talk about TTCI. Now I will tell you, this picture, it looks kind of green. My people that do these slides for me promise that this has not actually been doctored. I personally don't believe it because I've never seen it that green out there. It is the High Plains Desert of eastern Colorado, and TTCI was first put in place back in 1971, but it was not known as TTC. It was the High Speed Ground Test Center, where if you go to a little railroad museum that's down in Pueblo, you can still see one of the vehicles that was tested at that High Speed Ground Test Center. Jet engines, and holds the land speed record for rail vehicles, and nothing much came of it, as you can tell. So this organization, once it went through that testing, in the early 80s there were some questions with the federal government about why are we testing? Do we really need this center? Should we continue it? And the Association of American Railroads said yes, this is very, very important for the North American rail industry. In fact, then so much that the AAR said, let us run it for you. And that began a very happy partnership between FRA, our landlords, and the Association of American Railroads. The company, TTCI, Transportation Technology Center Incorporated, was actually formulated in January 1st, 1998. So when we talk about TTC, we're talking about the facility itself. And when we're talking about TTCI, we're talking about the company. TTCI is a small business enterprise. We are a wholly owned subsidiary of the Association of American Railroads. We're operated by an on-site management team, of which I'm the representative here tonight, and we're guided by an independent board of directors. Excuse me. Just to let you see who our board of directors are, there's a few folks up there that the railroaders in the room might recognize some names on here. They constitute, for the most part, the chief operating officers of the North American Class 1s. In addition, we're lucky enough to have Ed Hamburger, who is the president of the Association of American Railroads, is also the president of the TTCI board. And in addition to that, I'm lucky to serve on that as well. So let's just talk some basic facts about TTC now. Okay. This picture is not doctored. I have seen these beautiful sunrises and sunsets at TTC more times than I care to count. So while we're not green, we do offer beautiful, beautiful western skies. TTC is a 52 square mile facility. We are about 5 miles wide and about 10 miles tall, and the land is actually owned by the state of Colorado, leased to the federal government, and then we operate it on their behalf. We have 48 miles of active track. That doesn't include all of the connecting track that we have. We have laboratory equipment that's capable of testing full-size cars and locomotives, and we have a training center with life-size props to help people learn how to respond in the unlikely event of a derailment. If you look at TTCI now, we are about a 270 plus now employees. Over 100 of those are researchers with everything from a bachelor's degree all the way through PhDs. We have laboratory engineers, we have individuals that work on standards for the Association of American Railroads as well as inspections. We have operations personnel and administrative staff, like any company. So what does TTCI do? We have our basic products and services that you can see over there are researching, consulting, training. We have technical support that we offer for the industry. And if you look at where our revenue comes from, about 25% of it comes from AAR research, the strategic research initiatives that we work on every year. Another 20% comes from AAR services, helping with the committee work, looking at training, looking at inspections through our mechanical inspection division, through our Bureau of Explosive Inspections. We also do a lot of research for FRA, with about 23% of our annual revenue this year coming from FRA research. And then finally, the rest of it is commercial work that we do for organizations both in the United States. For example, Union Pacific could be a customer. We'd have suppliers to the rail industry that could be customers. We also have customers that come from all over the globe. So you can see TTCI has a little bit of a diverse makeup in who we serve and what we do. This is a quick picture of the test site itself. You can see it's about 5 miles wide, about 10 miles tall, and you can see the tracks laid out in it. Lots of room on the northern edge for expansion, Kevin.
Oh yeah.
We'd love to expand. Here's the tracks that we have today. We've got 5 specialized test tracks that we use for different types of testing. Our high tonnage loop is to about a 2.7 mile oval. That's where we run our FAST test, the Facility for Accelerated Service Testing. FAST runs anywhere about 25 MGT per month in a controlled environment. And the purpose of FAST is to look at the life cycle of primarily track components. Our railroad test track, the RTT, is a 13.5 mile loop. We have a maximum speed on the RTT of 165 miles an hour. And I can attest to the fact that it has actually been, we've had trains out there that have been operated at that speed. The Acela train on the Northeast Corridor was qualified at TTCI, and I think it went maybe a few miles over 165 miles an hour. That a whole 13.5 mile loop has overhead catenary. The transit test track is a 9 mile loop. We can test up to 80 miles an hour, and that has electrified third rail for running transit traffic. We also then have the worm loop, where we're looking more at how the cars respond, or the rolling stock responds in a very unique environment, as well as the precision test track, which we use to see the response of rail cars in an extreme environment. This is some of the pictures of the full-scale lab testing we have with our vibration test unit and the simulator. We can test anything up to a full-size locomotive in those particular test areas. The squeeze fixture can take a rail car and see what its ultimate strength is. And the impact wall is, I have to admit, we were talking about this at table 1 here during dinner. It is one of the most fun days an engineer can have, is to watch something crashing into that wall. We are all out there with our hard hats and our boots. Amazingly enough, you need about 170 people to run that test, it looks like. We've got wonderful individuals that can do a number of different types of work, including finite element analysis, computer simulation modeling. A lot of what we do is also very specialized, like our communication-based train control work. And if you want to know about communication-based train control, or PTC, we have a fully functional PTC test bed at our facility that's on the RTT, that we have locomotives that are PTC equipped, we have fully functional wayside units, and we can simulate what actually happens for both IETMS as well as the Amtrak system, the ACES system. So we can run both types of testing there at TTCI. Now, we don't actually supply PTC systems, but we can do all of these particular things to allow individuals to test in a controlled environment, to provide system solutions, and to look at interoperability. I also said about 20% of our revenue comes from AAR services, and that's going to be where I'm moving now, is what do we also do besides the particular research. One of the things that the AAR has is a number of different committees that work to develop rules for interchange. And those technical committees are staffed by TTCI employees. We don't write the rules, but we do supply the information to the committees upon their request that they can use to discuss, to formulate rules, and to appropriately promulgate them using the AAR practices. We also then are going to be the ones that are going to help them with industry advisories and regulatory issues. We do also have compliance monitoring, so the quality assurance process, the mechanical inspections, and the BOE inspections are all done by TTCI employees. Damage prevention and loading services, to make sure that we have appropriate ways of loading freight cars, that we understand how to block particular loads, are all done through people that work for TTCI. And then finally, we have the Security and Emergency Response Training Center, where we have a full-size 38-car derailment out there that allows first responders from the rail industry, from petroleum and chemical companies, as well as local, state, and tribal first responders, to be trained to respond appropriately in the unlikely event of a derailment. We like to think about this particular aspect of training as the same number of people that raise their hand to say that they've been trained for CPR. A lot of you are trained in CPR and have never used it. Our goal as TTCI is to have people trained to respond to emergency situations and never use it. Unfortunately, this year I think there's been a couple of incidents that everyone's aware of where it has come into play. And we're working hard to make sure that we work ourselves out of business, but before we do, we make sure that we have people trained to respond in the unlikely event of a derailment. So let's talk now about strategic research, now that you know a little bit more about TTCI and the things that we can do. The industry program is one that is put together by the Association of American Railroads, and so we get funding on an annual basis to do research. But you'd ask yourself, well, how do you decide what research to do? And there's three things, first of all, that we're trying to look at when we do research for the industry. It's improving safety is number one, it's improving reliability, and then finally it's improving efficiency. The best research that we do can help us in all three areas. Our research is primarily in one of these four areas for AAR, either mechanical, in engineering, in vehicle track interactions, the wheel-rail interface, or understanding specifically what happens under heavy axle loads. One of the things that I saw today was work that was done with human factors, looking at grade crossings and how individuals interface with the particular devices that you see at grade crossings. That's not something that TTCI does. When you look at our strategic research program, there's a number of different inputs that come into it. There's an industry roadmap that tries to look ahead over the next 20 years to see what things do we need to look at down the road. The current committee priorities talk about what's happening now. What help does BNSF need today? What things does CSX need solved this year? We also then have information that we get from our affiliated labs. We have a number of different universities that are in the affiliated labs program, and they're doing some research that is a little bit farther out in terms of its practical applications to the rail industry. But from that basic research can spring research that we can take on and get it to the point that it is developed for the industry. And then finally, other industry efforts that we're aware of. All of that information goes together to try to figure out how we have our strategic research program structured. This is a couple next two slides then is up-to-date information from the two basic committees that look at research. And the first one is the HAL ERC, the Heavy Axle Load Engineering Research Committee. So if you look at this, these are the top 10 issues that, from the engineering side, that they would like to have solved in priority order. And you can see number one is improve rail flaw inspection. On the mechanical side, we have the same thing. These are the current priorities from those committees as far as what they would like to see. Automated cracked wheel detection systems. There's one in service right now in the United States. It's on Union Pacific. There's some issues as far as what can we do to make that better? What can we do to have that be promulgated throughout the rest of the industry? And you can see there the rest of the top 10 research priorities. Those research priorities then are run through a process, and out of that comes the 2014 Strategic Research Initiative. So you can see there the things that we're working on as far as AAR's research money: heavy axle load implementation, track integrity monitoring, special track work, and all the rest. So let's just talk now about some research highlights from 2013. I've picked one that is related more to the rolling stock side and one that's related to the engineering side, to the track side. We had 29 projects in 2013. We had 3 that were completed, and we had 6 new projects that started. If you look there, this is a quick list of the 2013 research projects that we have. The bold letters, the larger letters, are the Strategic Research Initiative, and then the individual projects underneath those. And we're going to look at 2. We're going to look at optimizing hot box detector scanning, and then heavy axle effects on rail joints. So, optimizing hot box detector scanning. Bearings. Bearings are a real issue for the railroads. Unfortunately, wheel bearings get internal defects, and when they get internal defects, if you don't catch them appropriately, they can overheat and actually burn off, so that you have a derailment where the end of the axle is just a small nub and you've got about 20 cars in the ditch. So making certain that we can understand how to find those bearings that are overheating is a real need for the industry. But at the same time, you need to make sure that you have detectors in place that don't stop trains when it's not necessary. So we want to make sure that the detector technology that we have in place only finds the defective bearings and never finds a good bearing and calls it bad. So we want to try to optimize our ability to scan for what we call hot bearing detector. When you look at research and you look at our industry, it's 150 years old. It has a rich tradition and a rich heritage. A lot of the things that we do simply because that's the way we've always done them. And one of the questions that we get to ask at TTCI is the way that we've always done it the right way? Is it the best way? And so what we looked at with these particular hot box detectors to say, there's different types of technology out there, but there's also different ways that you can put it into the track structure. You can have it close to the rail, you can have it far away from the rail. Is there any difference as to how these detectors act depending upon what technology you have, and more importantly, how you actually install it? And so we were able to do that at TTC. We were actually looking at different systems from different vendors, as well as different ways of installing them in the track structure. That's one of the joys of having that particular facility out there. It is revenue type service without having revenue trains. It is a fully production environment that the results that we get, we feel are applicable to the North American rail market. In addition, we can do something out of TTCI that, trust me, you would never be able to do in revenue service. Run known bad parts. So we were able to get bad bearings, ones that had been tagged for overheating, and put them into a train environment and run them out at our facility. Because if they fall off the tracks, they're not going to hurt anyone. There's 52 miles of desert out there that we can do this with. In addition, we were also, to make sure that we could get the full range of the problem here, we were able to have some of these bearings actually have heating elements installed on them so that we could get a known temperature signature. And you can see there that that's showing some of the temperature profiles that were resulting from the work that we did. So, let me talk to you about what this chart says, because for me, especially coming from the mechanical side of the industry when I worked for BNSF, this was really, really interesting. In a perfect world, none of these bars would have any length to them. They wouldn't be above the line, and they wouldn't be below the line. So in a perfect world, 0, which is the 2 lines down from the top, would be the answer for every one of these bars, because we knew what temperature we were supposed to be generating for each one of these bearings that went by a detector. You can see, however, that in some cases, depending upon what supplier you were, and more importantly, where you were installed, you could be anywhere from 100 to 120 degrees cooler on the detector than what the bearing was actually reading. Those were instances where you would miss a hot bearing because that particular detector at that particular location wasn't able to read the bearing properly. In addition, especially when you look at this particular graph, in some cases you can see that there's very little length to that middle line, run 22, but run 21 and 23 showed a tremendous difference. A lot of variation from run to run. And so taking this data, we're continuing on with this test to be able to come up with an appropriate way, or the best way, of having these detectors mounted depending upon what system that you have. The goal here is to make sure that we find bad bearings and don't stop good trains. So let's talk about insulated rail joints now. For most of you who know the rail industry, if you look at our track structure itself, there's always going to be a weakest link. At this point in time, one of those weakest links has been rail joints, the insulated joints. And so the research initiative was to determine the root causes of insulated joint reasons for replacement, to make sure we knew what kind of environment that these things actually had to live through, and to come up with some alternatives. These are reasons that you would have for replacement, either adhesive problems, foundation issues, debonding of adhesive, or pull apart. We've come up with some different designs that are either that we call our next generation insulated joint. There's some unique features in here. You can see how this one is a different design than just the butted together ends. And at this point in time, we have some of those, after we tested them successfully at TTC, that we have them actually in revenue service. So far, we're generating tonnage on each one of these particular insulated joints, and now it's just a matter of time until we can demonstrate the types of results that we'd like to have. But the goal is to actually get about 1,000 MGT on an insulated joint before it has to be changed out. You can see where we started back in 2004 with about 200 MGT. So the idea here is to have an insulated joint live as long as the rest of the track structure. And that is a brief tour of TTCI. And with that, I'll take any questions.
You're in a position being in Colorado along that corridor, Pueblo, all the way to Fort Collins and beyond to Cheyenne. They're talking a lot about commuter rail. Are you guys involved with that though?
We are involved a little bit with commuter rail. We are involved with various organizations that offer commuter services. A lot of times though, when it comes to commercial work, the only thing I can really say is that we're involved with it and I can't really comment on it. But TTCI actually does do work both for freight rail as well as commuter and transit organizations.
So you see some progress there then?
Pardon?
You see some progress there then?
I think so, yes. Yes.
What about high-speed rail? What's your, how much research are you doing in that area, focusing on the high-speed rail program?
Not as much as we would like to, I think, is number one. I know that there are some research projects that we're doing that we are helping other organizations who have competed for some Federal Railroad Administration funds. I know there has been some talk over the past 10 years as far as putting some upgrades into TTCI so that we can even run at faster speeds. But at this point in time, we've got a 13.9 mile or 13.5 mile loop that can run up to 165 miles an hour. So most of the work that is currently being done in the United States, that is sufficient for the test speeds that they need. There obviously is some of the stuff out in California that's not. Yes?
Are you doing any research on improving tank cars, design of tank cars themselves so that you won't have oil spills?
There's, as far as tank cars are concerned, there has been some research that's been done with high pressure tank cars as opposed to the non-pressurized cars. There are some recommendations that have come out of testing that's been done at TTCI for both the industry as well as FRA that I think we'll be seeing here from AAR soon. Yes.
I'll ask one more.
Okay.
So your track structure, you have rail, and you're looking at connections. Do you do any work in the metallurgy of the steel, the metals that are used in the?
More on the wheel side than on the rail side, but certainly as far as we actually have a wheel steel that has been quote-unquote patented that TTCI has. We are looking at both premium and intermediate steels for rail, but we're not actually the ones involved with the coming up with the alloy, but actually testing rails that are presented to us by the industry. So FAST has a large program looking at both intermediate and premium rail steels, and then we also have a program where we're looking at different types of wheel steels from different manufacturers.
Well, one last question then. You have a sound and vibration research group?
We have a vibration group, but not for sound.
So my question is, you probably work on trying to reduce vibration to the train itself. What about the vibrations that leave the track and disturb the people on either side of trains? I mean, is there any research being done on that?
Not currently. We're currently not looking as far as squeals or anything else. There's a lot of research that's being done more in Europe with noises, especially with high-speed trains, and especially as high-speed trains are going through tunnels. Yeah.
You mentioned, excuse me, bridge research is one of your priority areas, SRI 10, I think it was.
Mm-hmm.
What issues are you looking at there?
There's a couple things that we've done on bridges, and it's really kind of fun out there because TTCI is high plains desert, so there is no water around. But the good news is there's a whole lot of sand, and so we can dig in that and install a bridge in any one of our tracks wherever we want to. So we don't have any water running underneath it, but thank goodness the structure up on top doesn't know that. There's a couple different areas where we're involved with. Some has to do with work that's being done with new composites, fiberglass, types of structures where we can reduce weight and still have the same life or better life. The other thing that we're involved with, we've got a couple of bridge sections in place that have been donated by railroads that have already seen decades of service. In fact, one of our bridges has seen its 100th birthday. And the question that we're asking is, those are out in the heavy axle load loop, is how much surface life is really left in those? What type of crack growth do we see? Because we can monitor and look at each one of those cracks in that bridge, have really understood how long it is, how big it is, where it is, and then look to see how it changes and its length and its width and propagates over time with tonnage. And what we see is that there's a lot of the bridges at least that we have seem to have a lot of life left. The other thing that we can do with those bridges is look at different ways of repairing cracks and can we do them where they take less time to repair, are less costly to repair, are easier to repair, and understand how those repairs actually will last over time.
Thanks.
Mm-hmm. Yes?
In your track structure, do you have any cases where you're not having a ballast-based track structure, but more track fixation on the side of the track?
We've got some sections of slab track in the heavy axle load loop. It's a fairly small section, but yes, there's a couple of places where we don't have ballasted track. It's not a major focus for us at this point in time, though. And I have no explanation for the Denver Broncos, so please just don't even ask on that. Good heavens. Okay. Well, thank you very
I'm gonna
much.
ask one more.
Okay.
I'm gonna ask one more question before we thank you. So we are a university that's fairly new still in the railway side, and obviously you guys do a lot of research. We are getting involved in the research. Do you have any advice on, what are some of the paths that we can take, or what are some of the things that we can do to try to increase our portion of to be a stakeholder in the development of technology and research for rail industry?
Okay, that's a very good question. Certainly having a lot of industry representatives here that can hear the story of Michigan Tech is one of them, and I think so. This Railroad Night is a great thing. Maybe not in February, but
Looking into it.
secondly, you're doing a lot of good stuff in areas where you're not repeating research that others do. If you look at some of the other universities, with University of Alberta, UIUC, Virginia Tech, they all have some different areas of expertise. And looking at the different problems that the railroads have from those lists that we showed you up there, and not trying to reinvent the wheel with something that someone else is doing is probably the best thing that you could do. Some of the work that you're doing with human factors is not stuff that we've seen from other universities, and I think it's very promising. That's an area where, especially when you look at TTCI, we are not doing that at all. I know that's an area, though, that FRA has a lot of interest in. And that's a great way to move forward. Not the only way, but one of the ways. Okay, thank you.
So we do have a little token of appreciation for you coming all the way to the UP. We have the Michigan Tech Transportation Institute hat for you, and of course, you do have to have the coffee cup and the bottle opener. Thank you very much.